Hello, my name's Martin Ives. I volunteer for a charity in the UK called REMAP, who try to provide solutions for people with various disabilities that will improve their quality of life. My current project, which I happened to mention on LinkedIn yesterday, is to connect a pushchair to a wheelchair. In this instance, it's a Cybex pushchair and a Karma wheelchair. My post on LinkedIn garnered a response from a fellow REMAP volunteer on the other side of the country from me, who has got the same task. Now, I can't imagine that he's got the same two products that he's got to link, but questions were asked, and so I'm creating this video not as a this is how you have to do it, but more as a this is how I'm doing it. But if you've got any ideas on how I can improve what I'm doing, then I'm open to suggestions. If it results in a better product, embrace it, Martin. God damn it, embrace it. So, I'm playing to my strengths. I know a bit about 3D printers. I've got two 3D printers. One's an FFF machine and the other's a DLP machine. And for not my last job, but my previous job, I spent almost all my time designing in sheet metal. And for this particular project, it immediately called to my strengths, to my knowledge of 3D printing and of sheet metal. I thought that I could produce something relatively quickly and relatively inexpensively to meet the needs of the client. One of the things that I did when I saw the client for the first time was I went round with an app on my phone, a clinometer, measuring the angle of these tubes and the uprights on the foot support on the wheelchair. And you may or you may not hear birds in the background. Those are bonkers parrots. The one currently shouting is one called Charlie, who hates me. He is a psychopath towards me. Partner, he loves. Me, he just wants to kill. Anyway, back to the subject. So the clinometer obviously took some photographs. More will follow. And I've used some of the photographs, this one in particular we'll see later, within SolidWorks as a sketch assistant. So, next image. Here's the wheelchair. Sorry, pushchair. Braining gear, Martin. Always helps. You can see that I've put some little marks on the tube to give me an idea of distance. This is not with the initial pushchair with cot on it, but this is more the buggy for taking the child round. And you will see in the next shot that the angle of dangle of the foot support, leg support can change. Notice also that you've got storage underneath the pushchair, which the client wants to maintain access to. Back to the original image without the text. This is showing what the client and myself to be the optimal position for her to be able to access her child when it's born and in the pushchair. So this has been a guiding image throughout. Whilst I was there, I took some rough dimensions, hardly precision, but it gives an idea. First thing I modelled was the two upper stays on the back of the pushchair, because very early on, while I was with the client, I thought that what I needed was a saddle to go across those uprights in pressed aluminium with clamping shelves going down onto the tube of the pushchair, and this becomes a fixed part, or permanently fixed, as permanently as screws are, to the pushchair until such time as the lady needs to dispose of the pushchair if she wants to dispose of it. Modelled this shell, just one side, modelled it as a part, and then put a cut through to split it into two parts, and I just export it as an STL file as the two parts and print it, and I've created a mirror of it. So for the full set of 4 parts, you've got 2 of one hand and 2 of another. This is an early but not the first concept for the yoke, which will mount to the part we were looking at previously, the saddle, and then hook on to some supports on the footrest support on the wheelchair. This is the an assembly of the saddle with all the clamping shelves, screws, clamp plates go through behind there, again laser cut aluminium, and dowel pins onto which the yoke will locate. And here you have an assembly showing the yoke mounted to the saddle. My original concept was to use Zeus fixings or something similar, because the lady wants to be able to remove this so that when her husband is using the pushchair, he doesn't have to worry about barking his legs on the yoke, so it has to come off. I was in contact with a lady at Southco who was extremely helpful and came back to me and said, ultimately, why don't you use lynch pins? And I said, I can't use lynch pins. Yeah, and then I thought about it and I thought, yes, I can use lynch pins and it'll get rid of a lot of problems. So always when working with apprentices in the past, I have said to them, someone's going to have a better idea than you, embrace it. And that's part of this video, that hopefully maybe someone will have a better idea of doing something and will suggest it to me, and I will embrace it. So I apologized to the lady and said, when she came back to me with more information on Zeus fasteners, I said, well, actually, I've gone with your linchpin idea, and sent her a picture of what I'd done. So this is the left-hand assembly that will mount to the footrest support. In this particular iteration, it's evolving, and more of that later. I'm using a shoulder nut. Newer versions are using a shoulder screw because they give me a bit more flexibility and length. This one was perfect, but something with my last visit threw a spanner into the works, and so I'm going to have to do a third visit tomorrow, in which I can take some more measurements. So this is a reasonably complete concept model. You can see that I've added holes round which I've got some 3D printed shells, and that's to allow the lady to handle this thing more easily, to mount it. And then I've got this locking arrangement shown in grey, and I'll do a video of that and this part and attach, put it into this whole video so you can see what I'm doing. It's got a limit on it so that it can't guillotine, or at least the chance of guillotining fingers is reduced. And I'm using neodymium magnets to hold everything in place, not springs. And as you'll see in the video, the neodymium magnets seem to work quite well. One of the problems I've had is that Cybex, their phone system didn't work at all for me. Just you press the button and it just disconnected you. So I raised a support email request. I got an automated response and then never heard anything more, because I was asking for CAD to tell me what the precise dimension is across here, because without it I'm going to struggle to make. I could build in some flexibility. In fact, I have built in some flexibility, but it's much better if I know the dimension, not measured with a tape measure, but measured with something better than that, or ideally just refer to some CAD. But as they weren't playing, I went out and bought this. Initially I looked at the 500mm, they were out of stock. I contacted Machine DRO, they were very helpful and they came back with a suggestion, but between them coming back to me and my initial inquiry, I actually went out and bought this one from them. It's not breaking the bank, and for what I'm doing it's more than accurate enough. This obviously is the lady sat in her wheelchair. Now as you look here, it looks like the footrest supports converge. On my second visit, I discovered that they actually toe out. I didn't pay enough attention to the wheelchair. I suspect the whole geometry of the chair is such that the main wheels, the drive wheels, are towed out slightly to make it easier for the person in the wheelchair to work the wheels, and that toe out works all the way through to the footrests. And while Klarna Mobility have been very helpful in providing some data, they felt that the angle of these would be dependent upon who's using the chair and how it's set up. So I've got to do a third visit tomorrow to measure the angle. This is something that I did get back from Klarna. Initially they were very much, and very understandably, we don't want to share any CAD with you, period. It's our intellectual property. So what I did, I sent them a simple CAD model that I created by using SolidWorks to model something over a photograph. And I put some dimensions, well, initially I put on dimensions, and then I just put in question marks, A, B, C, D. And they came back with this image which answers my questions, which is a huge help. And I thank them greatly for it. The ladies, well, I think it's a lady in the UK, and I think it's a lady in in Taiwan, have both been exceptionally helpful within the limits that they can be, and it's been a delight to have them working so well with me. And that's where I reach the end of this particular element. I will shortly spark up SolidWorks and show you where the design stands now. So in SolidWorks, this is almost where I'm at. It's a reasonably complete model. Easier if I was using my 3D Connection Space Mouse rather than just an ordinary mouse. But you can see how I've got the linch pins going through a tab which has been pressed up, and I've 3D printed, or I will 3D print, support for the linch pin to stop it flapping about. I've gone up on the dowel pins, and they were 6mm, they're now 8. And down here I've got a support post on each side for the linch pins, so that when they are taken off, they can be put onto there and held securely. What's not shown in this model is I've actually bought some lanyards that will allow me, stainless steel wire lanyards, that will allow me to permanently tether the linch pins using a fixing through that hole to this part. Now, I could have left it at that, but I thought there's always the possibility that someone's going to offer this up to the pushchair, and the linch pins are going to drop down between the yoke and the saddle, and then they're going to have to take it off again. So why not make life easier for everybody concerned and have these posts into which the linch pins, when they're removed from their working position, can be put into a storage position to make life easier for all concerned. So that's what I've done. They were relatively cheap from Amazon, and I'm reasonably happy with what I've got. The outstanding concerns now are with the next iteration of this part. And being a numpty, I've not set up to open the next part, so I will have to file, open recent, let's browse the recent documents, and it's going to be that one. And so this is the latest incarnation of the mounting system for a shoulder screw onto which the yoke will latch. You can see I've modelled in some inclination on the support, footrest support, and that's achieved with the 3D printed part. And so I've got an inclined plane through there, 2-degree angle on it at the moment. Made this extra wide. I've got this cut out here, and I should have started a print running, but I haven't. I'm going to print this part so that I can take it down with me tomorrow for a is it fit for purpose test. Will it fit onto the wheelchair footrest? And I've already printed out, go on tab, I printed out last night, finished at 1 o'clock this morning, this part. So that is another, does it fit, does it work? And it'll just make me more comfortable that when I actually come to get parts made in aluminium, when I come to print this part, if it fits reasonably well, I might put some or all of this cut back. But if there's any doubt in my mind, I might just leave it and not worry about it. This is a top-down design, so all the holes in this are being driven, or all the fixing holes for the M5s, keeping everything together, are driven by a sketch on the 3D printed part. I just find it so much easier to use at times top down. I know it's frowned upon in some circles. Certainly if this was a production part, you'd want to break all the links and make them independent, or so I'm told. But in this instance, it works really well for me to do top-down design. That cut is left, or has been put in there, so that on the wheelchair, there's a fabric support that goes behind the lady's heels and Achilles tendon area, so that her feet do not, or particularly the foot that doesn't work particularly well, doesn't slide off backwards and under the chair or anything like that. So this is the big question, is what is the inclination of this particular part on the wheelchair, which is necessitating a third visit. I really didn't think about it enough at the time, failure on my part. Ultimately, these are just showing ordinary nuts at the moment. I'm very much inclined to go with dome head and Loctite them in place, or alternatively use Nylox, and possibly, just even now as I think about it, 3D print a cover to go over everything. So it has been and continues to evolve this design. One of my problems is saying enough is enough, put it down, it'll do. But at the moment it's still a work in progress, so excuse me, I'll just add a bit on the neodymium latching, and then I will publish this video to the web where you can comment on it. If you are going to comment on it, please keep it constructive, and I'll say it now, I'll say it again later. Thank you for watching. These are two trial parts printed on my Zortrax M200, which must be more than 8 years old now. They've been printed in Zortrax Z Ultra T, and I don't have a countersunk screw, so I've had to use what I've got in the way of an M5. These holes are as they are because they are nominally just over 10 mil and will be in the finished 8mm aluminium plate that I intend them to be made from. And I want to make sure that the magnets are properly bonded into the aluminium, so that's why I've got them like that. So what I will finish up doing for assembly is putting a piece of tape behind, squirt in some adhesive excuse me, and then insert the magnet so that the adhesive then comes up past through the grooves to make a good and permanent bond. Anyway, the purpose of this video is more to do with the neodymium magnets. So you can see I've got a neodymium magnet in there, which is full width, that goes all the way through 8mm, and this one is 4mm. Now there's a natural repulse, which is really helpful for me until it comes to the critical point, and that ain't moving very easily at all. You have to use quite a bit of force on that. Now these are some of the strongest magnets that I could get. I will have to speak to the client tomorrow and see if I need to actually, on the production part, have this in plastic, but have something coming up here that she can put her thumb more easily onto, a bigger land, to make it easier to move, because she says she does lose use or suffers reduced function in her hands at times. But this is, so that and one there will lock down on the yoke, and then this belt and braces closes on there. So there you go. That's where I stand at the moment with the design. Hopefully I will get something made before the child is delivered, which is supposed to be early August, but the lady says they're not going to let her go that far because she does have 1 or 2 health issues. And one thing I should mention is that Obviously I'd like to have the parts, the aluminium parts, anodized, and I contacted a former employer of my other half, because they do a lot of aluminium stuff and have stuff anodized, and they pointed me at a company, and that company came back and said, we'll do it for free, which for me is just awesome. Thus far with REMAP projects, I've had nobody come back and say, oh, well, you can have this stuff if it's for REMAP. But these guys have come back and said, you can have it for free. Now, I'm not going to mention the name because I don't want them inundated with people wanting stuff for free. But it's just awesome that they've done that for me. Or said that they will do that for me. Right, here endeth the video. Hopefully people will find it interesting. If you have comments, as I say, if you can keep them fairly positive, that would be much appreciated. I do accept criticism, but I get, like everybody else, I suppose, upset if it's just destructive. Thank you once again. I hope it's useful, and cheers.